Holcim and industrial point of view about progressively tackling the challenges for cementitious materials. Players by Mr. Christophe Levy. So this session will be chaired by Dr. A.K. Chatterjee, Fellow, Indian National Academy of Engineering and Chairman, Kumbh Technologies. So I would like to invite Dr. A.K. Chatterjee on the dais and chair the session. Thank you, sir. I would now like to invite I would now like to invite Mr. Christophe Levy, Scientific Director, Holcim Innovation Centre, France, on the dais. Thank you, sir. I would like to call upon Shri Amit Trivedi as NCP representative to join the dignitaries and introduce our chairman, sir. Thank you.
Good afternoon, delegates. Chairman of the session, Dr. A.K. Chatterjee and Christophe Levy. It's my honor and pleasure to introduce Dr. A.K. Chatterjee. He is Fellow Indian National Academy of Engineering and Chairman, Kumbh Technologies. He is an eminent material scientist, nearly 5 decades experience in the cement and concrete industry. Doctorate from Moscow State University, Russia. Early career as faculty at Indian Institute of Technology, Kharagpur, India, and later moved to Cement Research Institute of India, now NCB. So, Fellow of Indian National Academy of Engineering, Indian Concrete Institute, and Indian Ceramic Institute. Published several books. Most noteworthy are on cement production technology, principles and practices, and intelligent and sustainable cement production, transforming to Industry 4.0 standard, published by Taylor and Francis Group, USA. Lifetime Achievement Awards by the Indian Concrete Institute, Association of Consulting Civil Engineers, Confederation of Indian Industries, and Cement Manufacturers Association of India. So I welcome sir in this session, and I request Dr. Chatterjee to please conduct the session. Thank you.
Hello. Well, friends, good afternoon to all of you. I'm still expecting that our delegates are coming in. I think after lunch break, generally we have this kind of a problem, so it may take a few minutes for them to really sit down here in this hall. So far as Christophe Levy is concerned, I really don't know it's very important or it is necessary for all of us to introduce him to this audience. He is known to the Indian cement fraternity for a pretty long time. At least I knew him for decades now. And, cutting short all the big things that are written here, I would only say that he is the science director, you call it, right? Scientific director at Lyon, I don't know how many of you had opportunities of visiting Lyon. I had, and I must say that should be treated as a kind of a pilgrimage for the researchers in the cement and concrete field. And he is obviously one of the pillars of Lyon Centre. Despite some of the changes of hands of management or administration, Lyon, I think, still keeps its character, and that's due to people like Christophe Levy. Today, he is going to speak on a subject which is so close to our heart that a corporate establishment, how it has really faced the challenges of moving from removing one obstacle to the other, and therefore that will be a very pertinent and relevant lesson for all of us who are trying to achieve some of the things which have not been achieved in our country so far. He is one of those speakers, I do not know how many there are even globally today, who says that I don't want 40 minutes. And all of you should be little careful that he says that I want only 25 minutes to speak, but that shouldn't limit us if he is trying to economize on his talk. I'm sure Dr. L.P. Singh wouldn't mind if the audience tries to really fill up the time gap that he would be leaving after his talk. So, Christophe, I think it's a pleasure. I consider it's a real privilege that a talk from a person of your stature, I am somehow or other got into the net to chair this session, and I look forward, along with all my delegates here, to listen to you on this subject.
Can you hear me? Good afternoon, everybody. Anja was right. I'm privileged to work in Lyon, but I'm especially extremely privileged to be a speaker today. I'm extremely happy to be in India. I love your country, and each time I can come back, it's a good opportunity for me. So thank you to LP Singh for this invitation, which will be for me an opportunity to try to show you what we are doing at Holcim in order to progressively tackle the two main challenges that every concrete and cement player should have in mind: the target of zero CO2 emissions, but also the target of zero natural resources, if it's possible. So thank you, Anja, again for the very nice presentation. In terms of time, I think the compromise was 35 minutes, so I will try to do so. A quick presentation of our group. So my group is about 63,000 people in 60 countries, a turnover of 27 billion Swiss francs, euros, it's about the same, or dollars. We made a lot of progress in the past years regarding the CO2 reduction and CO2 emission reduction. I will talk a lot about that, clearly. We are still aligned, and we will be aligned with the Paris Agreement to stay under 1.5 degrees. We've got 2,300 operating sites. I know that in India it looks small. In Europe it's a lot. So we are operating, we've got operations in cement, in ready-mix concrete, in precast, in construction demolition materials or waste. We are also in tile adhesive, in roofing, in insulation in facade. But the bulk of our activity is clearly around cementitious material. As Anja was so nicely speaking about, I'm very privileged. It's a real chance to work in this beautiful lab. I think it's the most beautiful lab. I'm not very objective, but I think it's the most beautiful private R&D facilities in our domain of cement and concrete. You are most invited if you come to France to see us. It's a very, very nice, Lyon is a nice city, and the lab is really nice to visit. We've got a special hub also to demonstrate, to showcase our innovations. It's quite big, 15,000 square meter. We are 225 researchers from 22 different nationalities, and this is very important because I'm a strong believer of mixing the culture. We've got Indians, by the way, quite a lot, 6 to 7. We've got many French, but we've got people from all the countries, and it's very important to have this mixity of culture. We are now developing more than 600 new products per year, which is quite a lot, with 300 patent families. Obviously, the main focus, 80% of our research is dedicated to CO2 reduction. It's funny because I'm working for Holcim, for the group, even the name were different before, for 37 years, and I must admit, it's my fourth time in this lab. I must admit that 15, 20 years ago, CO2 emission was not a big issue. I'm ashamed of it, but it's a reality. Today, it's absolutely key for us, and the remaining 20% is approximately only on circularity. So that's the key topics, CO2 emissions reduction and circularity. So we have the big chance to have a lot. We've got more than 100 laboratories with 3,000 equipments. We have a very, very wide range of people, competencies, equipment, obviously, from material analysis to cement to concrete. So on the left, you can see we've got a marine lab. In the middle, you can see a real batching plant that we have in our facility. And it's really real because the mixer is half a cubic meter, which is quite current in India. So it's a real but very accurate batching plant. We're working also on construction engineering and on durability. And we've got all these competencies, which makes me happy to come every morning because I know that I will learn something new, which is true. So regarding our priority R&D projects, again, they are here to try to drive decarbonization and circularity. That's the two main topics for us. So starting with, on the top left, with green operation, decarbonizing Holcim, then building better with less, which means decarbonizing construction, and the top right, making buildings sustainable, which means decarbonizing cities, and last but not least, building new from old with circularity or circular construction. Starting with the first one, green operations. You all know this kind of roadmap. This is our net zero roadmap. It's really for us, and you will see something which is a bit special to us, which is not a very good news, by the way, but it's important to share it with you. First thing, there is no silver bullet. We need to work on all the levers, all the steps, having less CO2 in the clinker, less clinker in the cement, less cement in the concrete, less concrete in the building systems, and having clever, intelligent, smart design in order to use less material. We made a lot of progress, I think, in terms of CO2 reduction in the past decade, let's say 10, 15 years. So today, it's true when you compare this roadmap with GCCA roadmap or Semburo roadmap or Indian roadmap, we've got a big CCUS part because we made a lot of progress on the others. And now we've got this issue of 44% to be captured. The CO2 must be captured, then used and or stored. That's why we started already. We have 7 projects in Europe, and EU is granting us this, and it's very, very important to us. On the bottom, you can see our split in terms of CO2 for 100% of CO2 emitted. We've got a scope 1, which is in dark blue, and then we've got 5% on scope 2 and 20% on scope 3, which is transport emission. So becoming a net zero company, it's a long way. And there are 4 main levers for that to reach net zero cement. The first one is obviously decarbonizing energy and green fleets. We've got the first plant in Rensnay in Austria, which is using 98% of alternative fuel. And we are launching more and more plants like that. The average of the group is 15 to 20%, but we've got first of the class in Austria. On the top right, it's clear that circular construction is a game changer. And I saw many nice presentations pinpointing this. And it's true that today we are really working on how to use, we call it CDM instead of CDW because we consider that it's a real material. It's growing, and it's very important for us to use them, and we'll see that later, at the alternative raw materials level, but also for as a SCM. We are developing, obviously, low cement carbon formulation with different SCM. We are also a lot now developing the separate technology, which help us to save something like 3 to 5%. It's important to have this separate grinding, which was not at all the case before. And again, we've got these 7 EU granted projects for CCUS, and 50 others are coming worldwide. And we commit, and I know my group will do it, in 2030, we will have 5 million tons capture. So on greener formulations, nothing extremely new, except we are using SCMs, numerous different SCMs that we were not using 10 years ago. So for instance, you can see steel slag beneficiated steel slag, road sludge. These are things also like pepper mill ash and so on. Reclaimed fly ash, which was not the case at all 10 years ago. Today it's a real lever for us. But the focus is clearly on calcined clay. Today we are proud to have 8 cements in 8 plants using calcined clay as an SCM, and 12 are coming soon. And for the CDM, for the fine part of the construction demolition materials, we've got 5 cements in 5 plants using this technology, and 15 are coming. So it's not lab, it's not the future, we are in. Second pillar is building better with less. So decarbonizing construction, there is 2 avenues. First one is low carbon materials. Second one is smart design. Low carbon materials, in addition to carbonated product in precast, which is something that I heard also during these 3 interesting days, which is something that we are starting now in Poland. We have 2 big worldwide brand names. EcoPact is our brand name for low carbon concrete, lower than 30% compared with reference, with normal concrete, which represents 1.5 billion euros, which is it's big. And we've got EcoPlanet, which is our again brand name for the cement below 30% of reduction of CO2. So I must admit that when I look at EcoPact, a lot of formulations were well known in the past. It was fly ash concrete or slag concrete. It was well known. What we are developing now, and we are at 28% of our global sales in ready mix, which is not ridiculous. We want to reach 50 and then 100, but today it's not ridiculous at all. We have developed 2-3 years ago a new generation of EcoPact, which represents already 6% of our sales in ready mix. And to do that, we have 3 levers. The first one, the lever 0, is a day-to-day optimization to be very, very good in everything we're doing. including digitalization, by the way. Lever one is clearly the binder. I mentioned it before, by using slag, fly ash, nothing new, but more and more calcined clay, reclaimed ash, and also concrete fines. The second, which is a bit more original, is to use a big volume, a high volume of limestone filler. We need to have a good paste, even with less clinker, to have a good workability and also a good level of strength. So the idea is to have a sober use of cement, but obviously, because we are out of the standards, we are performance-based, and I know it's a discussion, we will have the discussion later on for India, but it's absolutely key for us, and we are very much oriented in this idea of performance-based. And as you can see in the triangle, in the middle, we are out of the standards. We are exploring these new areas in the triangle clinker, limestone, slag, or clinker, limestone, calcined clay on the right. And we are, for us, EcoPact is not a niche market. It's really a mass market. And when you look at the graph on the bottom left, it's clearly between, let's say in India, M20 to M40, the target in order to decrease the CO2 footprint of this concrete. So for smart design, we've got different avenues, different solutions. We've got a brand name which is Dynamax for the high-strength concrete, nothing very new. But we are developing it in order, with high-strength concrete, you can make lean design, thin columns in order to save materials and save CO2. 3D printing is I love the subject. It's not an easy task. We are now making money in affordable housing. This beginning of next year, we will build the first J+2 buildings for social housing. If we all stay with mortar with a high amount of cement, it won't work. In terms of CO2, it's not the right avenue. We need to switch from mortar. It was easier to start with mortar, I can understand. But we need to switch from mortar to concrete, and concrete to low-carbon concrete. And this is very important if we want 3D printing to be successful. We are working also with ETH, University in Zurich, on funicular concrete floors, so like a vault, in order to avoid, it's working only in compression, so we don't have any traction, so we don't have steel. I hope it's not me creating this. So these funicular concrete floors save 70-80% of materials and 70-80% of CO2. Ductile is ultra-high performance concrete, developed 25 years ago, used for facade, as you can see here, or for overlay, reparation, rehabilitation of bridges or highways. There is a new startup that we acquired in Switzerland, which is called carbon pre-stress concrete, which is very, very interesting. We have developed with them very thin board or slabs, 4 centimeters instead of 20 centimeters, so same flexural strength, same behavior, so it's 5 times less in terms of material. So you can imagine that the CO2 is much, much lower. And in fact, it's a high-strength concrete, concrete, with 2-dimensional continuous pre-stress carbon fibers. So we've got pre-stress, which is extremely strong. So you replace 20 centimeters of normal concrete by only 4 centimeters. And we are working also with MIT on this very funny, very interesting idea of small modular elements, which allow you to make, with the same elements, only one element, you can make columns, beams, floors. They will be post-stressed, and they can be easily dismantled and rebuild somewhere else. So I think it's amazing that it's like a Lego or IKEA. I really believe in it. Not tomorrow, but it will come. So the third pillar is making buildings sustainable, so decarbonizing city. we have developed several things. One of my baby I'm very proud of is Aerium. It's an insulating material as good as expanded or extruded polystyrene. It's a mix of cement slurry with a surfactant-based foam. You mix the two, and you have a stable, recycled, no fire resistance, no volatile organic carbons. Really a very, very, very interesting foam that you can put to insulate the attics, the roofs, or the holes in concrete blocks. And we are transforming a normal concrete CMU, normal concrete block, into an insulating concrete block. It's working very well. At the scale of the city, we are developing living or vegetalized walls. It's working very well. Today we have made our first pilot in Australia, 240 meter long and 6 meter high. It's working very well, and I can tell you it was not easy. I failed a lot on this topic 12 years ago, and today it's working. Hydromedia, which are our brand name of pervious concrete, permeable concrete, you know the idea, but when we joined this kind, when we link or put together this kind of concrete with vegetation, tree, plant, earth, we are able to fight in a very efficient manner against the urban island effect. And we can decrease by 6 degrees C the temperature in this area. I think it can be interesting, especially in Delhi, or in India, not in winter, but in summer. We also we have a subsidiary, Elevate, which is developing cool roof and green roof, and we are also working at developing what we call bioactive marine concrete, either with 3D printing or with porous concrete, in order to multiply by 5 the growth of the algae and of the fauna of the fish, and it's working very well. Last and important point is circular construction. Trying to build new from old. What we are doing is we develop different technology, and I saw a few one during these 3 days, in order to separate with, thanks to abrasion or attrition, separate the coarse aggregate from the paste or from the sand. With coarse aggregate, we transform this CDM into very close to virgin aggregates. Really, it's amazing what we can do today. And with the rest, with the 0.4 millimeter, or with the paste, we can use them as alternative raw materials. We can use them also as SCM, especially if we mineralize them. So in a mill, we are injecting CO2 in order to capture up to 40, 50 kilo per ton of this recycled sand, which is a lot. And we are also transforming this inert recycled concrete sand into SCM thanks to thermal activation. And we've got some pilots today on these topics, and it's very promising. What I wanted to share with you today is, and I'm very proud of it because I proposed it. It was not that easy. On the beginning, people were very, very puzzled, and we have been successful. Last September to December, we pour the first 100% fully recycled concrete building. So it's a J+5 and a J+6. And this building will be completely terminated at the end of the year. We pour so 1,600 cubic meter. It has been a real success thanks to our partner, an owner, a developer, and a contractor. And we use, again, fully recycled concrete components. So another world premiere was recycled cement. We mix anhydrite and slag with recycled clinker. So it was a world premiere. Today we are able to do it in 4 different plants, 3 in Europe, 1 in Canada. Not using 1 kilo of limestone, not using 1 kilo of clay. We are only using industrial byproducts around the plant, bringing us calcium, silica, iron, aluminum, all what we need to make a clinker, and we do exactly the same clinker. And we can control this, and it really works. And it didn't work once, but we did it many, many times in 4 different plants. Regarding the recycled aggregates, I couldn't take very good quality aggregates, as I mentioned before. So we took average recycled aggregates, not that good. If you look at the density, it's 2.06, it's not excellent. The water absorption is very poor, 7 to 8%. It's an issue, but we knew it. And I wanted to prove that we can do it with far from perfect recycled aggregates. There are clearly far too much paste attached on the mortar. And we are using recycled water, ready-mix plant processed water on rainwater. And here are the mix design. On the left, you can see the mix design. There is nothing special for this, so it's a C2530, which means M30. Nothing very special, except we had to put 160 kilo per cubic meter of fly ash because we needed some additional paste, because there are a lot of absorption because of the coefficient of absorption of the average aggregates. So we need to compensate with more paste to have a good workability. As you can see, the slump value was good and the workability was good over 1.5 hours. Strengths are very good too. For M30, it's on cylinder, so it's very good. Everything was perfect, including durability. You see with resistivity or the carbonation was good. 2 things were not that good. I must admit that we need to make progress, and if we use good quality aggregates, we won't have this kind of issue. First one is pull-out test. We had 11 MPa in terms of 18 MPa, because again of the too much absorption, and so the adhesion between the bar, the rebar on the concrete was not so good. It was not bad, but it was not so good. So we had to double the anchoring length of the rebars. And the elasticity modulus was only 21 GPa instead of 30. So we had to add 1.5 centimeter thickness. Instead of having a 20 centimeter thick slab, we have 21.5 centimeter. We can solve this by using good quality recycled aggregates. Globally, it was a success. The contractor was extremely happy. The concrete was beautiful, easy to produce, easy to transport, easy to place, nice facings, and again, the structure is close to be finished now. And no, it has been a real success. I'm very proud of it, and I hope that in 5-10 years, we will see many construction like that. Because again, we didn't use any natural resources. This, I think, is a revolution. So I'm telling you for 20 minutes now that we are the best in the world. This is not true. And we need to work with external people, and it's what we are doing. And there are 2 families of external people which are supporting us, helping us. The first one is clearly the academia. The partnership with academia is absolutely key. We are working with many universities in the world. We are financing and supporting 22 PhDs in 8 countries. I'm very proud of this. I'm very happy to work with 3 fantastic universities from India, working with IIT Delhi here, IIT Hyderabad, IIT Madras. You are lucky, I'm speaking to the industry people, you are lucky to have this kind of level of universities. Just use them more. They do a great job for a small amount of money. It's really a pity not to use them. The second external family helping us is the startups. So we've got a subsidiary called Holcim Maker Ventures, with organizing in our lab in Lyon, accelerator. It's not an incubator, it's an accelerator. We are dealing with startups which has got a TRL of more than 5. And we are organizing every 2 years a 6-month session where we are offering market access, marketing expertise, technical expertise, even making a pilot with them. And we are in the 4th session today, and we have been able to accelerate 42 startups, which is a good start. We are also making venture clienting, which means that we are the early tester of the new startup solutions. And obviously, we've got some venture capital. So now before closing my speech, I'd like to, in a very humble and kind manner, share with you some messages that I like to share with the attendants. And I see in the attendance students, which is our future. So I will start with them, to the academia, but also to my peer, to industry. So to the student, I'd like to share with you the love I have for industrial research. I'm a pure product of industrial research. I really love my career. I work 40 years now, and I'm very proud of what I've done, and especially I had a lot of fun. So it's why I would like to speak to the students and tell them that academic research is fantastic too, but industrial research, I think you should think about it, because I understand that especially in India, not so many students, when they've got their PhD or their postdoc, they don't go that often to industrial research. Maybe it's a pity. That's why I'm asking you, dear students, 7 questions. Depending on your answers, you may think about staying in academia, that's the green boxes, or go to industrial research, that's the blue. So what matters most to you, students? Is that to understand things or to make them work? I like to joke about that some professors, they don't care if it doesn't fly. What is important is to understand things. And vice versa, us in the industry, we don't care to understand things as far as it works. It's not true. But it gives you a little spirit of the difference. Why do you make science? Why science is important for you? Is it for the beauty of science? Is it for the progress of science? Or is it to develop inventions and in a way making money? What keeps you from sleeping? Is that a very complex equation? Or is that a customer's pain point? In industrial research, customers is absolutely key, it's everywhere. We need to be customer-centric if we want to be a good industrial researcher. What is your favorite paper? Is it a publication, scientific publication, or is it a patent? I've got a few publications, I've got 80 patents. I'm not saying it's good or bad, it's a different way. How many topics do you want to tackle in 10 years? 1, 2, 3, 4, 5? Stay in academia. 10 to 50? Go to industry, which means that it will be on the surface, it will be a varnish. You don't go deep on 50 projects, it's not possible. But you see a lot of different things. Again, it depends on what you like. In terms of options for job type, usually in academia, you've got a few opportunities, whereas in industry, you can have lot of opportunities because you can go to operations, then marketing, for instance, then come back to research, then go back to operations in production, in sales, in management. So this is interesting if you like to change type of work every 3 years or every 5 years. Again, it depends on you. And what is your dream job in 10, 15, 20 years? Do you want to replace your boss, your professor, or do you want to become a manager? So, dear students, if you tick 6 or 7 green boxes, go to your professor and tell him, I'm going to replace you in 10 years. If you tick 6 to 7 blue boxes, come to me at the break with your resume, okay? What is important also is to go from one side to another. Start with academic research, then go to industrial, then come back to academia if it makes sense. You remember the 2 excellent speakers yesterday. They are very good examples of this. Karen Scrivener and Thomas Manchai, it's exactly what they've done. And they have been extremely successful in their career. Now I would like to speak to academia, to professors. I would like to ask you in an humble manner to try to choose the right topics with a real impact. Who am I to tell you what is wrong, what is right? I know. But what I know is some topics are extremely important for us as industry people. Some are, let's say, less important. And with Karen and 2 colleagues from industry, one from Sika, one from Heidelberg Materials, We have written this 30 pages technical Rilem letter. I encourage you to take a picture of the QR code to have access to this paper if you don't know, about the research need for cementitious building materials. It's a focus on Europe, but to be frank, it works in India, it works everywhere on the planet. And with Karen, we set the priority, what we think are the priority topics with real impact for the planet, for the humanity, for the CO2 reduction, obviously. And we share 30 key questions to be solved, to be studied. And this is what we call the watermelon. So I did this graph in order to simplify, if possible, what are the key domains where I encourage the teachers, the professors to work on. So you've got the different domains: clinker, to concrete, to admixtures, to durability, recycling, CCUS, and then you've got the subdomains around it. And we put in dark green the most important subdomains where I encourage you, professors, to work on, which means clearly clinker, low clinker cement, low cement concrete corrosion, which is very important because we are dealing with low pH. So in terms of durability, we think that it's the most important point. Recycling, obviously, for the reason I mentioned before. And globally, the CO2, the CCUS, the CO2 carbon capture and storage, and especially mineralization, because it's a nice way to capture CO2 without having to store it 5 kilometers down in the crust. And last message is to my colleagues, to my peer, the industry people. The first commandment will be, I think, you shall differentiate your products, not to die. It's obvious to all of us, that's great, but I think it's extremely important. And also, in order not to die, we really need to work now on the CO2 reduction through innovation. The second one is you shall innovate big size, think big, which is at scale. I used to make that mistake to work on small niches. It's very interesting, it's funny, but it doesn't change the world. And we need to make the change, the world changing. And it's very important to innovate impactfully, at scale. You shall launch many initiatives in parallel. It's not that obvious. Usually we make task A, then B, then C. The brain is like that. I encourage you to make to launch many initiatives in parallel, because commandment number 4, which is for me the most important, is I encourage you to fail. Fail again, but fail quick. Don't stay years and years on the same topic. Change. Doesn't work. If you think it's very complex, it can work, go to universities. They are here to help you to understand the mechanism of action, to make real progress. You shall make mistakes, because nobody should care in your organization. It's important to let you make mistakes. You have the right to make errors. You shall combat also the non-invented here syndrome. I know what I'm talking about. You shall reinforce your internal expertise. Hire new people. Hire people from a different world, with a different experience. They will have a different angle of view on your key subject. I think it's very, very important in your lab to have a reinforced expertise on the key subject. Another point which is very important is you should partner. I apologize for those who are doing already it, but you should make more and more partner with the whole value chain of construction, which means partnering with owner, partnering with architects, partnering with engineering companies, partnering with contractors and subcontractors. So this partnership will bring you a lot in terms of what are the needs, what are the pain points, how can I improve my products and my solutions. Obviously, a key message is to work with others, externally, to work with universities. And again, you've got, I think, some of the best universities in the world. So use them, exploit them, work with them. I think it's very, very important to work with universities, and some startups too. And then you shall be proud of what you're doing and have fun, because making industrial research is really fun. With this, I'd like to conclude on the fact that we will be successful in reaching net zero cementitious materials worldwide if all stakeholders collaborate together, all of you, together, if governments offer adequate incentives and adequate grants on the right topics, on the good, impactful topics, if the useful knowledge is clearly shared and transferred, and if the construction industry as a whole take risks and move fast. With this, I thank you very much for your attention.
Well, friends, I think we sat through a very interesting presentation. Towards the end, he has given several guides, particularly the youngsters and the students, and who intend to have certain professional directions. Maybe from the student community, if there are some, would you like to really react to the points that Dr. Christophe Levy has really presented? Any individual volunteering their wishes amongst the youngsters? The youngest person, you know, has raised his hand, I know, in this hall. So please, get going.
Thank you. Thank you, Christophe, for excellent and inspiring talk.
Thank you.
You described not only the various approaches that Holcim is taking in controlling our temperature, but you had advice for students and industry people. I have two. One is a small detailed question, and other is somewhat broader one. So detailed question, you described very well this low carbon concrete. We gave the details. I was wondering what good would it do to have 2 kilometers of polypropylene fiber?
2 kilometers?
2 kilometers of 2 kilogram, I'm sorry. Which
Oh,
was,
yeah.
yeah, why that? Because as you know, it adds a lot to the carbon.
I can answer. I forgot to mention that we had, it's a very good point, I'm sorry to have forgotten to mention it. We had to add 2 kilos of PP fibers for fire resistance.
Oh, for fire.
It's a code issue. I don't think we need it. It's a code issue in Europe, because when you are using poor quality recycled aggregates, you've got mortar, you've got water, it can spoil out. I don't think so, but we have to follow the code.
Didn't hear that. But then a broader question, you may remember in the first panel discussion, we had the chairman of the cement companies in India mention that there are two things. One is what is good for environment is also good for business, and what is good for environment may not be bad, may not be good for business. And I think that all the different things you mentioned that Holcim is taking probably falls in the first category. So I like to mention what is your comment on the second one, that is good for environment and not good for business. And an example, you may know that the Holcim had recently a plant in Norway where they take out CO2 from cement production and store it in the ground. And that requires a substantial subsidy from the government. So that probably falls in the second category. So I like to know what's your take on that.
No, it's a very good question. To be very fair, the Breivik in Norway is not us, it's Heidelberg, but we are doing exactly the same with 7 different projects coming soon.
Heidelberg, not Holcim.
Yeah, but it's okay.
I'm sorry, I made a...
No, don't. It's not an issue. And we are doing exactly the same thing with 7 projects, and 50 others are coming. Yes, you're right. It's a lot of money. That's why I was saying that the 44% is an issue. We are going to try to avoid as much as possible the storage, as much as possible. That's why we are doing everything first. In the CCUS, I consider that part of it, maybe 1/3 of it, will be mineralization, mineralizing olivine, for instance, mineralizing CDMs, mineralizing steel slag, mineralizing many things to capture CO2 without being obliged to put the CO2 3 or 5 kilometers down in the earth, which is a pity and which is very costful. Look, you're right. I mean, to have like Breivik, or the plans we are going to make the 7 projects in the coming years, it's easy. You double the cost of your plant, and double. I hope so. That's only double. And you add another 50% on the cost of maybe up to 80% on the cost of cement. Yes, you're right, Professor Shah, you're right. I'm not sure it's not right, it's not good for the business. Today it's an issue. We have the chance to be in part of one of the countries of the European Union, which is going to give us a lot of grants. We're speaking about a lot of money. Again, we commit to capture 5 billion tons in tomorrow, 2030. We need this money to help us. But one day we know that these grants will be over. And we have to find a solution. And the solution will be the carbon tax. It means that to produce a cement with a carbon captured, which means close to zero cement in a way, will cost more. It means that the ready-mix customers, the contractor, must pay a higher price, and it means that the building will be higher in terms of cost. It's a fact. What do you want? You want to save the humanity or not? We have no choice. We will do it. Same in the other industry. I think it's worse in the steel industry. So we will do it. I disagree on the fact that it's bad for business. It will be a new business, and we will have all to adapt. The cost of construction will raise, yes, sir. But you know, what is the percentage of cement in the cost, in the global construction, in the given building? What was the percentage of cement cost globally? 1 to 2%. Okay, if you multiply by 2, it's 2 to 4%. It's not a good news, but it doesn't change completely the world. So I'm more optimistic that what you mentioned before, hopefully.
Thank you, and I'm concerned, especially now in US, whether we get...
I'm not sure we can hear.
Yeah, I don't know what to know. Thank you.
You're welcome.
Okay. Did Dr. Singh, you wanted something, right?
I said like that, but okay. Thank you very much, Christophe. So, for our conference, I feel your lecture was like cement hydration. For any conference, it starts from here, then it goes like dormant, but you made it again, cement hydration like this at the 3rd day. So there are a lot of takeaways for the students, for the research institutions like NCB, and also for the industry fraternity. Thank you very much. Thank you very much coming from all the way from France and delivering your keynote lecture. I wish to thank you from my heart. Thank you.
My pleasure. Thank you so much.
Right. I was told that maybe another question can be taken. Please.
Professor Christophe, I am not as young a student as Professor Shah, but still as a student of cement technology, I would like to, the question which bothers particularly, which is more relevant for this part of the world, like India and Southeast Asia. Now, as with the passage of years, we have found solutions for energy, we have perennial sources of renewable energy like solar or wind or even hydro and even nuclear. But for cement, our limestone reserves are finite. And for example, in India, we have limestone reserves only for next 50, 60 years. Despite having utilized all the kind of or developed all kind of supplementary cementitious materials, having reduced the clinker factor to 50 or close to 50. Despite that, it may not last for beyond this century. And same will be the situation for rest of the world also. So what are the future materials for cement? Do we have to go back to the 17th century type of construction materials? Because I am not able to foresee what are the forthcoming building material technologies which are in the offing or on which research is going on in Europe. Can you please throw some light on it? Thank you.
Thank you for your excellent question. Two ways to answer. First, I started with green operations, mentioning the Austrian plant, which is using 98% of alternative fuel, which means no natural resources, and this will be accelerated. So we will use less and less fuel-based or coal-based energy. That's true. Today we are between 15 and 20 globally. Some plants are close to 100%. I'm happy to discuss with you in 10 years from here, and I'm sure we will reach globally, and not only us, globally at 30, 40, 50%. This will come. For the electricity, it was in my slide, I didn't mention it. We have 3 plants having 100% electricity for grinding and so on from renewable energy. Can be wind, can be solar, can be hydroelectricity. This is not science fiction. This is not the future. It's here. The second way to answer your question is what I mentioned by there is no silver bullet. We need to work on less CO2 in the clinker, less clinker in cement, less cement in concrete, and so on. In fact, it's not only a motto. It's a reality. We are going to use less and less clinker. We are all speaking about LC3. Great. There is still 50% of clinker. I'm sure that in 20 years from here, we'll use much less clinker. So, which means less energy. So I think, I'm not saying it's easy, but I think it will come. We are working as many competitors also on hydrogen. It seems, I'm not a specialist in this system, but I think this could be in the future a solution. It's an issue, but I think it's a solvable issue, if I may.
Anyway, I think, shall we get into this discussion little later during the break, because some programs have to follow this stuff. So thank you so much for such an excellent talk today afternoon, spanning a very wide spectrum from materials to ultimately motivating the youngsters and people. Thank you so much for this excellent talk. I hand over to Amit.
Thank you, sir. Thank you, sir. Now, I would like to request our Honorable Chairman to please present mementos as a token of appreciation to Plenary Speaker Mr. Christophe Levy. Thank you, sir. I request Shri Amit Trivedi to present memento as a token of gratitude to our Honorable Chairman. Thank you, sir. Ladies and gentlemen, that concludes the plenary session. The panel discussion too will begin shortly. Thank you all for your esteemed presence. Please remain seated. Don't leave the hall. Thank you.